Thank you. I'm very glad to be here. I also teach occasionally at Virginia Tech, so I decided to use Virginia Tech colors here today. That's what Virginia Tech looks like, and those stones are called Hokie stones. Hokie stones. You know, I've asking people here, so what are the bricks on your buildings called? Nobody's told me yet, so people think there must be a name for the bricks here, and you know, I live in Washington. It's near Georgetown University. Georgetown's bricks are darker. I grew up near Boston College. Boston College bricks are lighter. So I have a little bit of detail there. And of course, the most important thing is right down here. How many of you have ham licenses? That's terrible. You let these people in your wireless program without ham licenses?
We're working on that.
You know, I work at Virginia Tech with a woman who's an Iranian immigrant, and I said, you really got to get a ham license. She said, ham? You want me to get, no, no. She didn't. She's been in the U.S. for a while, but she had never heard that particular context. Now, I'm not advocating you eat ham. It's just saying you ought to get a ham license. But you guys ought to think about it because it teaches you some practical aspects of radio. And I will tell you, I have climbed Mount Fuji with a 2-meter radio in my backpack, and I learned a lot from turning on that 2-meter radio at the top of Mount Fuji. Think about what happens if you do that, and it's an interesting Duncan experiment to do that. Okay, here's a little bit of what I'm going to talk about. The basic issues that are in spectrum policy. Here is my background projected here on the time scale. This is from '85 to 2005. These are different frequency bands that I had a key role in getting into the commercial world. Prior to those dates, those frequencies certainly existed, but there was no commercial use allowed. There's a certain causality here, this 59 to 64, 75 to 77, 76 to 77, and this is 70, 80, 90 gigahertz. I tend to think high. Let me tell you, it feels good to have an article published in IEEE Journal. It also feels good to go into Best Buy and see a product that wouldn't have been there like Wi-Fi unless you had started the ball moving. Both are good, but it's a different side of the field, and my career has sort of been doing both. So why is this really important? Let's think about how new technology gets developed. You know, maybe you've never taken a business course, an economic course, but if you had an idea and you wanted to take the ball and run, you need money to turn your idea into something that works, and particularly something that's mass-produced. So cash flow, how much money you've invested. So if you have this greatest idea for a new radio system, you have to spend money developing it, and that runs up negative cash flow. That is, you spend money on R&D, you can't sell the thing, but you have to spend money on R&D. Maybe nobody teaches this in engineering courses, but that's how real products get developed. And you spend more and more money, and you get into what's called the valley of death. That is, you're spending money, you're not getting any income. Finally, at the end of the valley of death, you start producing a product and people start buying it. Now, usually you have to sell product at a loss initially because you have so much money sunk in it. But I will leave that to others to explain to you why that's true. This is the integrated cash flow. Unsuccessful products never really get above the zero line. Moderately successful products get above it. Very successful products get there. That's in general for any type of product that you might want to sell, whether it's a radio product, a PC device. You spend money in R&D, you get deeper in the hole, and if it's successful, you get out of the hole. The problem is for wireless technologies, you get involved in regulatory delay. That is, once you have the product developed, you often, if it isn't subject to routine approval by regulators, you have to go to places like the FCC and beg, can I please sell my product? Can I pretty please sell my product? And you end up spending more and more money and getting no income. And this is what complicates investment in radio R&D and why the private sector is increasingly reluctant to invest in radio R&D, because there are a lot of things you can invest in. You can invest in integrated circuits, you can invest in new computer displays. There are lots of high-tech products you can invest in that don't require these special approvals that new radio technologies involve. By new radio technologies, I don't mean minor variants of Wi-Fi. I mean new radio technologies. And this is why regulation is important. Now, here are some examples of recent case studies of new technologies that how much the delay was of regulatory approval. And interesting, by contrast, these are corporate mergers. FCC has to approve major corporate mergers in the regulatory business, in the telecommunication business, and it typically does it in 6 months to a year. By contrast, new communications technology, this is direct broadcast satellite, which is basically what DirecTV is. PCS is second generation cellular. This is the ongoing TV white space, which actually is much longer than that now. There's a problem in the communication policy business because these technical decisions are taking much, much longer than the business decisions, and they're both complex. Are these more complex than that? I don't think so. People got very, very upset over these corporate mergers. They both generated thousands and thousands of pages of comments to the FCC, and yet FCC can't deal with them in a time-sensitive way. Spectrum policy, why I happen to like and made it my career, which I'm not advocating anyone else do, is, that's why I have so little here now. I used to have more when I started working there, is an interesting mixture of technology, economics, and legal issues that's stimulating intellectually, at least for some people like me, but important to the economy. And when all three fields work together, it helps everybody. Why is this important? Spectrum is the key ingredient to wireless telecom, and telecom is a key input to economies, societies, and national security. We need telecom, not just because telecom's a big industry, but telecom has a synergistic effect on all other parts of society and our economy. Now, if you remember nothing else I say today, please remember this slide. Wireless is more regulated than other technologies. This is the International Telecommunications Union's international regulations on radio. I could have put the FCC ones there. In wireless, they're just as real as Maxwell's equations. Just as real. Now, you may not like them. They're not God-given, they're man-given. They do indeed change. But within the time constants here, and the time constants here are typically like 5 years or 10 years, within those time constants, if you're designing a system that you want to do something other than fill pages of IEEE journals, these two things are just as real. One line takeaway from this that I hope you remember. Okay. And regulatory things can delay implementation just as bad as a design error. Design errors can really screw up an R&D project, so can not anticipating a regulatory problem. How is engineering different than physics? Engineers not only want to build things that work, they want to build things that work, meet size limits, cost limits, weight limits, and being able to be sold is an important limit. Doing something in the lab but not being able to sell it is not really engineering. Engineering is doing something that can be used in practical thing, and that's why I think it's important for people in wireless to at least have a basic understanding of these things. And let me talk about briefly the macroeconomics of telecom. The telecom industry in the US grosses in the order of $10 to $11 a year. It's a big industry, and a lot of people say, therefore it's important. And it is important, but it's more than that. The industry is becoming more and more wireless, but here is an interesting view from Europe that amazes me that the US government doesn't seem to think this way, but I think they don't deny it, but they don't like to think this way. ICT is Eurospeak for information communication technology, basically the information thing. There are some jargon differences between Europe and the US. Contributes to productivity growth and increased competitiveness of the European economy as a factor in growth and job creation. When you have a good telecommunication infrastructure, it makes your whole economy more efficient. GM is a major user of telecommunications. If its telecommunication was not efficient, it would have trouble competing with Toyota, Volkswagen. Okay? It also creates new jobs. Now I have a mention here, Amazon. Why do I mention Amazon? Is clearly not a telecommunication industry. But Amazon would not exist if the internet didn't exist. So the creation of internet stimulates non-telecom businesses and jobs, that we don't classically view as that. And indeed, here I have eBay. eBay, no, not a telecom thing, but again, if it weren't for internet, you wouldn't have eBay. And eBay stimulates economic growth in its own. Travelocity, same way. FedEx is more confusing. Let me tell you, when FedEx got started, the traditional mobile radio, which is used to dispatch taxis, was not adequate for FedEx's business, because FedEx's business, they had to constantly tell the truck where to go and keep track of packages. So FedEx developed something which is similar to what you know as your iPhone today, but it was much clunkier. It was 25 years ago, but that type of mobile technology to allow the truck driver up-to-date information on where his delivery was and acknowledge deliveries was first developed for FedEx. And if we had not had a communication infrastructure that allowed FedEx to do that, they also depended upon airline deregulation, which has been discussed a lot, but the telecommunication deregulation that allowed them to quickly build an innovative wireless system was key to getting FedEx off the ground. And while you think this applies to developed economies, let me say for those of you who are interested in developing countries, this was an article from the Washington Post several years ago that pointed out in rural India, where fishermen were basically in the subsistence business, fishing each day for themselves and selling a little bit on the side, incomes went up significantly when cell phones first became available, because the subsistence fishermen could find out market prices for different types of fish each day before they went out and optimize their fishing for the day to maximize income. So even in third world economies, giving people access to up-to-date information on pricing can contribute to economic growth. It's not just making GM more efficient, it's even increasing in relatively simple economies, giving people current market information can make a big difference. All right. Okay. Spectrum policy is sometimes said as painting the stripes on the information highway. Here is a stripe painting machine, in case you wonder what that thing is. It's supposed to prioritize the uses of spectrum, manage interference, facilitate new technology, but in general, spectrum policy is also used as part of industrial policy to gain trade advantage. This you see in other countries, not much in the US. So in Europe, there is only one type of cordless phone that can be sold in Europe. DECT. You have better cordless phone technology? Tough. The only cordless phone you can sell in Europe is DECT. You have a cell phone technology you want to sell? Tough. The only type of cell phone technology you can sell in Europe is GSM or the new 4G. You want to sell CDMA? Europe and Japan use spectrum policy as part of industrial policy. Is that good? Is that bad? I'm not going to go into that, but it's very, very different in the US, where you have much, if you go buy a cordless phone, you have a lot more choices than you have in Europe. Other countries handle things differently. In the UK, we have one agency called Ofcom, a relatively new agency. It deals with spectrum, broadcast, and telecom. It spends no money on R&D. Whereas in Japan, those of you who speak Asian languages might realize that English and Chinese characters don't match, but that's the way they are. There is one agency, it spends money on R&D. I happen to hate that idea, and the reason is, if an agency spends money on R&D and then decides which technology is good, it tends to favor the projects it spent its money on. And when you look at communication policy around the world, some are like Canada. Singapore is very much like Canada. Our northern neighbor, on the other hand, has two agencies, one that deals with spectrum. It spends money in R&D, but it has so little money it doesn't matter. They separate broadcast policy in a different agency, which I happen to like, because broadcast policy is very, very political. And when you mix broadcast policy with technical policy, agencies tend to focus too much on broadcast policy. In the US, we have a two-phase system. My former employer deals with telecom, broadcasting, and spectrum use by everyone other than the federal government. This other obscure agency, NTIA, deals with spectrum use by the federal government, neither of which spend any money on R&D. Now, there are two different legal systems in the world. You may wonder, why am I saying this? It matters. Interesting, an Israeli who wrote about this thing said, the difference is religion. that the two legal systems, one tends to be in Catholic countries, one tends to be in Protestant countries. Okay? In a minute I'll ask you why is that wrong. Think about this. The civil law system is in the blue countries. It dates from the Napoleonic Code, written by the Emperor Napoleon, and whereas the common law system, which we have in the US and most English-speaking countries have, dates from the Magna Charta. Now, why does this not depend on religion? When was the Magna Charta adopted? No, not that early. 1215, if I remember right. When was the Reformation? Hundreds of years later. The Magna Charta significantly predates the Protestant Reformation. You know, England was a Catholic country when the Magna Charta was adopted. It has nothing to do with religion, but it was amusing, this Israeli author, and I think other people make the same thing. As it turns out, these are the civil law countries are predominantly Catholic, but it has nothing to do with religion. England was dealing with common law way before that because it dates back to 1,000 years before the Magna Carta, but it was certainly enhanced by the Magna Carta. Civil law comes actually from Roman origin, so it even predates the Christian era, and was codified most famously by Napoleon, and it has the worldview that the proactive role of government tells people what they can do. So having lived in France, I can tell you that until 1904 in France, you could not start a nonprofit organization without permission of the government. Indeed, in Japan, where I used to live, only 15 years ago could you start a nonprofit group without the approval of the government. In the US, you just assume if you want to start a tree-hugging group, you can do it. But you couldn't do that in France until 1904, and you couldn't do that in Japan until 15 years ago. Whereas common law has the view, guided by the Magna Carta, that people can do what they want unless the government has a damn good reason telling them what not to do. These are two different worldviews of different countries in the world. Which one's better? You know, we're not here to make value judgments. We're here to just say this. Now, as a former resident of France, let me summarize the different views of the world in what I call the Saint-Exupéry dichotomy. Antoine de Saint-Exupéry was a writer of French children, well, was a writer most known perhaps for his children's book, The Little Prince. Actually, he wrote several other books. He died during World War II. But in The Little Prince, that's the Little Prince himself, there is a charming quote, "As for the future, your task is not to foresee it, but to enable it." And the two different worldviews in spectrum policy is, are you foreseeing the future or are you enabling it? In the US worldview, it's more of, let's enable the future. The government's not going to tell people how to run their lives or what technologies do. Governments tend to be bad at telling technologists what they should do. The US has more of a view of let's enable change, more, not always, more of the view of enabling change, not foreseeing change. Okay, but interestingly, nobody needs spectrum. People need ways to communicate. Spectrum is totally useless by itself. People need ways to communicate, and communication capacity is a function of spectrum and technology, and particularly infrastructure. You know, when you see cell phone base stations, the more base stations you put in within limit, the more capacity you get. You get more capacity through more spectrum, but the benefit of cellular is by putting in more and more base stations closer and closer together, you get more capacity. The rational engineer designs systems perform as a function of minimum cost. If spectrum is free and technology is expensive, what do you do? And what you learn in engineering school is, if you have different things you got to use and they cost different amounts, you get the best solution at the lowest cost. And if one of those amounts is spectrum, then you tend to use more spectrum. So which brings us to Marcus's first law of spectrum. No efficient technology is ever as cheap as free exclusive spectrum. If you have unlimited access to spectrum, go for the widest band solution you want. You want super wide deviation FM? If the marginal cost of spectrum is zero, let me tell you, wide deviation FM performs better than narrow deviation FM. And if you can use your political influence to get huge hunks of spectrum, go for the widest deviation you can possibly use. Interesting, people would argue that Wi-Fi is free. Wi-Fi is not exclusive spectrum. When you get Wi-Fi, when people make Wi-Fi, they know they have to share the spectrum with other people. So this applies to exclusive spectrum, like the military uses, like many other people use. The military is a big user of spectrum, and interesting, except in the UK, they do not pay for such spectrum use. To the US military, spectrum is free. The military pays for electricity, they pay for gasoline, they pay for airplanes, they even pay for land for military bases. But spectrum is a free good. That warps their decisions. And a challenge is, how do you balance military national security policy with civil spectrum use? That is a very, very difficult problem, but it's warped by the fact to military planners and military engineers, spectrum, at least in the US, is a free good. Where US spectrum policy is really made by there are the two agencies. FCC regulates non-federal spectrum use. It consists of 5 presidential appointees who are very, very political and generally friends of the president or the opposition party. And I've asked several former FCC commissioners, when you were under consideration, did anyone ask you your views on spectrum? And the answer generally is a laugh. To be appointed to these positions, the questions that tend to be asked there is, where do you stand on broadcast ownership and content, i.e. wardrobe failures? Or where do you stand on rural telephone rates, which surprisingly is a very hot political topic in Washington, even though the general public cares about it less. The other agency is NTIA. The president, POTS, the president of the United States, has authority under this law to manage spectrum use by the federal government, but he's busy doing other things, so he doesn't have time to do it on a day-to-day basis. In reality, this agency of federal bureaucrats from 20-odd agencies makes most of the real decisions, and that's the problem. It's the inmates running the asylum. It's the people who use the spectrum deciding how it should be used, and and paying nothing for it, and that's one of the problems. FCC, here are the 5 presidential appointees, very political, interest in spectrum management intermittent. The appointees really selected for knowledge of spectrum. NTIA, here's the head of NTIA, Larry Strickling, a very nice guy, but realistically, he is an assistant secretary of commerce. Commerce is not the most important agency in Washington. Assistant secretary in Washington is, a dime a dozen. He's not a deputy secretary. He's an assistant secretary of commerce. He cannot call up the secretary of defense and say, use less spectrum, because he's an assistant secretary of commerce. He is exercising the president's authority, but much as it hurts me to say this, under the Nixon regime, that was not the way things were. Under the Nixon regime, his equivalent under the Nixon regime worked down the hall from the president and was an assistant to the president and call up cabinet agencies and say, do it my way. And this was a change that came under the Carter administration and may not have been for the best. Spectrum balkanization. This is a hunk of spectrum. I hate this chart, but it makes the basic point here. This is a hunk of spectrum from 3 gigahertz to 4.2 gigahertz. It's sort of divided up into all sorts of people sharing on the various circumstance. A key thing is the code down here. Black means that's shared between the government, that is the people regulated by NTA, and the people regulated by FCC. So this hunk of spectrum, FCC and NTA have to agree upon. The red part is used only by the federal government, so it's only subject to NTIA, although at these boundaries, life is complicated. And the green part is regulated by FCC because the only people there are non-federal government users. This goes on up and down the chart in this breakup. Many different users, some regulated by one agency, some regulated by other agencies, some regulated by both agencies. It gets complicated fast. Do we have anyone Japanese in the audience? Japan has 2 words for truth. And much as the Eskimos have different words for snow, Japan has 2 words for truth. One word, tatamai, is sometimes translated as the truth as you want it to appear. Okay? And the truth as you want it to appear is the chart that that previous thing came from. It shows all the spectrum from DC to 275 gigahertz, and it's all neatly divided up in an organized way. So you would think, well, it must all be used. You would think that. Okay. The other word for truth is hane, which makes more sense for those of you who read Chinese characters. This is the actual truth. And this is a measurement that was done by FCC in 3 cities 8 years ago. I was involved in it. And it's basically 400 to 900 megahertz observed over 8 hours. So spectrum is this way, time is that way. And funny thing about it is, in Atlanta and New Orleans, red is heavily used, white is basically, the lighter colors are unused. Basically, there's lots of extra spectrum. The reason is, in reality, most spectrum, most of the time, is unused. This is why there's a lot of interest in dynamic spectrum access. San Diego is different. The reason is San Diego is unique in the United States because there's a military base in the middle of downtown San Diego. It's the only US city with a military base in its downtown area. But in general, military use and non-military use is orthogonal in space. You know, Area 51, there's lots and lots of military use there. There's no commercial use in Area 51. Yeah. Fort Hood, Texas, there's lots and lots of military use in Fort Hood, but hardly anyone lives there. You know, the problem of spectrum is really the problem of the major cities, and except for San Diego, there's no military use there. So here are some of the recent major battles in the FCC that I'm going to talk about. North Point, PCS is MVDDS is this issue deals with sharing the spectrum, which is best known for most people as where DirecTV is. PCS is second generation cellular. AWS-2 is related to third generation cellular, and here, as most people have heard about this, the current GPS controversy. All of these have a root cause, people trying to use spectrum more efficiently and trying to avoid what the FCC forbids as harmful interference. So what is harmful interference? Harmful interference is a phrase which is used 8 times in the Communications Act of 1934. Actually, I haven't updated this slide because in the February amendments it was added 3 more places. So it's now 11 times it's used in the law, but it's never defined. It's used in the IT radio regulations. FCC, it is defined in those things, but they all use the same definition, and no one I know has been able to find knows when that definition was written. I'm positive it predates World War II. Radio regulations, we know what really got started. What happened 100 years ago this week? Titanic, yes. The sinking of the Titanic was the major stimulus to radio regulation, and it would not surprise me if the definition actually goes back to shortly after the Titanic. That's the definition. It's a charming definition. If you can figure out what that means in today's technology, you're better than I am, because the problem is nobody knows what it means. When this was written, we did not have frequencies that were weather dependent. You know, prior to World War II, high frequencies were like 50 megahertz. 50 megahertz is not affected by weather. You know, we're now using a lot of frequencies which very different phenomena happened. We now have, especially with going to higher frequencies, we now have very different antenna techniques than we used to have. We have high, you know, prior to World War II, high gain antennas basically didn't exist either because the frequencies were so low, antennas would have to be so huge. So the issues that you get involved in, again, there's the definition up there, is HI, harmful interference, based on worst case geometry, infrequent geometry, or some percentile. Who knows? Definition doesn't say. What if interference is small compared to naturally recurring outages? Because some of the frequencies you now have natural recurring outages. That's why we have diversity and frequency diversity in microwave systems, because even in point-to-point microwaves, you have frequency-related fading. Do the incumbents or the haves who prefer status quo have the upper hand? How do you decide who's more important, the haves or the have-nots? If you're interested in this, I will leave with someone my copy of his PowerPoints. Here is a report that NTIA wrote a couple years ago that at least compiled many of the precedents. They were supposed to write a second report that said what they think ought to be done, but they squirmed out of it. And they were told by the White House under the Bush administration to do that, and they dragged it out long enough that the White House got distracted, and they managed to never do what the Bush White House told them to do. So let me talk about North Point MVDDS. Again, this is the band that DirecTV uses for these cute little 14-inch dishes on top of your house. And if you think about it, all the dishes in town point south because the satellites are over the equator. So a married couple, both engineers, he was an immigrant from Lebanon, she was a Texas gal, had this brilliant idea, oh, if I put a transmitter on the north side of town and illuminate the town from the north, I can get customers to point their antenna to the north, and I can use the same frequency that DirecTV uses, and there won't be any interference. So you can double the use of the frequency. So imagine an isolated town like South Bend, put a transmitter on the north side of town transmitting 12 gigahertz to the people of town, and you won't cause any interference with the DirecTV users because their antennas are all pointing south. Well, that's true when it's sunny. It turns out when it rains, rain affects the satellite path more than it affects the local terrestrial path. Who knew? Now, when you get DirecTV, I bet your friendly salesman at Best Buy didn't tell you, by the way, you get 2 hours of downtime a year. Anyone here have DirecTV? Were you aware there was downtime due to rain? I don't know what it is for Indiana, but for Washington, D.C., it's 2 hours a year on statistical average. It's interesting, it's less in the Pacific Northwest because they may have a lot of rain, but it's light, it's the heavy rain. So it's worse in Florida, not so bad in the Pacific Northwest. And what the FCC ultimately decided was that North Point, the nice married couple, could do this provided it did not increase the expected amount of interference, not the actual amount of interference, because it turns out the actual amount of rain varies all over the place. But there is a standard ITU model of what the expected rain is that God knows with climate change has nothing to do with reality, but it's the expected. And as long as you don't increase the expected amount of interference more than 10%, so in case of Washington, you increase it from 120 to 132 minutes a year, then you can go ahead with it. But that's the type of decision that gets involved. And there's nothing in the definition that tells you how to do that.
What was MITRE's role here?
Okay. Because of some shenanigans all the parties were doing, Congress passed a law ordering FCC to go to a third party to get third-party advice. FCC very rarely does that. The law that was passed was really stupid because it was impossible to meet. There was no one who met the definition that Congress had, and in a smoke-filled room, all the parties agreed that MITRE was interested in doing it, and while they didn't meet the letter of the law, that everyone agreed that they were objective, so FCC gave them, I think, $800,000 to do this. Now, I was the manager of that contract. That galled me that they gave them so much money, but people were so nervous over this, they said, let MITRE do whatever they want so they can't blame us. But MITRE did a very good analysis, which I would recommend to you, of what the issues were and came up with this deal. It was a good way to settle things. It was the only time FCC ever done that because they didn't have a choice. Okay, the PCS H block, PCS again is second generation cellular. Most cellular systems are frequency division duplex. The handset transmits on one frequency, receives another frequency, so there are two bands. This is the mobile transmit band, that's the mobile receive band. The H block is right there. It is not presently used. FCC would like to use it. UPCS, unlicensed PCS was a low power band that wasn't very successful. If you go to a Best Buy and see DECT European style cordless phone, that's what's in that band. There could be other things in it, but in reality, probably the only thing in this band are those low power cordless phones. So this band, FCC was seeking to use, and this gives you an example of how you get into real technical problems. The problem you get into here is the band here, it's 5 megahertz, it's 1915 to 1920. There's another band down here, 1875 to 1880, and son of a gun, if you do your math, 2F2 minus F1, remember intermodulation? There's a bad intermodulation problem. This one plus this one, if you have a receiver which doesn't have good filters and has nonlinearities in them, technical jargon, third order intercept point that's too low, then when this transmitter talks and there's somebody nearby in the B block, so there's someone standing within a few feet of you who's using this frequency, your frequency and his frequency correspond to his receive frequency. That's a problem. That's not an insurmountable problem because intermodulation is not divine in the Bible. Intermodulation is a function. You know, like fire comes from, what causes fire? Heat, fuel, and oxygen. You get rid of one of those, no more fire. Intermodulation requires three things also. Get rid of one of them, the intermodulation goes away. What are the three things for intermodulation? The three necessary conditions? Intermodulation, by the way, in this context is virtually always receiver generated intermodulation. It doesn't exist in the air. There is such a thing, there are other types of intermodulation, but in practice they almost never occur. The real problem in the policy business is receiver generated intermodulation, and it's a function of this mathematical formula. The frequencies have to be related in this magic way. It's a function of strong signals, and it's a function of both poor filtering and nonlinearities. If you had good filters and a high third order intercept point, you don't have it. But this shows you that this is not an obscure policy issue. This is something where engineering is an integral part of this. And this issue has been going on for 7 years now and still hasn't been resolved. It fascinates me. AWS-3, I was involved a little bit in this. This is the 3G band. This band is vacant. This is the downlink band. This is the band in which your cell phone receives in 3G. And the reason why this band is vacant, in Europe this band is used, is down here there's the corresponding set of frequencies for uplink where the cell phone transmits. And the frequency that corresponds to this is used by the US military and they don't want to let go of it, or at least they didn't want to let go of it. So all these frequencies, A, B, C, D, E, F, have corresponding frequencies down here, which are used by but this one had no mate. It was lonely, it was unpaired, we say in the jargon. So some former colleagues of mine at FCC said, well, if we use that for time division duplex, like the Chinese 3G system, we don't need a pair. Okay, there's a Chinese 3G system that's TDD. Didn't have to use the same exact system, but to show you they weren't the only ones in the world thinking this way. And they said, let's use it. Well, the problem is the F block turns out to be owned by T-Mobile in most US cities. And T-Mobile, strangely, put filters in their receivers assuming that this whole band was theirs. Was just like in Europe, all the band was used for cell phones and nothing else. Even though the FCC rules clearly said, they bought their spectrum at auction, and the FCC rules clearly said that this spectrum could be used for anything that was permitted under the allocation, which only said it had to be used for mobile radio. Didn't say what the band, didn't give the technology, didn't give the band plan. But T-Mobile bought the spectrum knowing there were no guarantees what this would be used for, and then was shocked to hear that someone wanted to use this for TDD. And under certain circumstances, if the TDD user was within a few feet of the T-Mobile user, and the T-Mobile user was at the upper end of F, not the lower end of F, in a couple other circumstances, you might get interference because of a strong signal adjacent to a weak signal. And T-Mobile had a huge fight. This was a big fight that dragged on for over 4 years. Interestingly, at the end of 4 years, FCC never reached a decision. Here's about T-Mobile. T-Mobile obsessed about low probability events. It could happen, but there's an article I wrote in Wireless Communications which pointed out if you have a T-Mobile user a few feet away from you working in an upper frequency in that band, you can sure as hell detect that he's there. He's only a few feet away from you. And if this T-Mobile is using at the upper end of the F block, one countermeasure this guy could be is, instead of using the lower end of this band, use the upper end of that band. That's not what people usually mean by cognitive radio, but at least some of the more flexible thinkers in cognitive radio think that any use of real-time information to choose your frequency, not just choosing a vacant frequency, but choosing a frequency knowing what a domino effect might be, is a reasonable use of cognitive radio. But T-Mobile wanted nothing to do with that. As we now know, T-Mobile, the owners of T-Mobile were trying to sell their US subsidiary, which they tried to do to AT&T for $25 billion. And when you're trying to sell a used car for $25 billion, you can afford a hell of a lot of legal fees. And in the FCC system, a few $1 million worth of legal fees goes a long way to cause total chaos. So I think what happened here is the owners of T-Mobile, in order to protect their $25 billion investment that they were hoping to cash out on, as it turns out they couldn't cash out on it, just created a total nuisance. UWB, ultra-wideband, a big controversy of 10 years ago. Ultra-wideband is low PSD, power spectral density, underlays under narrower users. That is, if you keep your power density very, very low but spread over hundreds or thousands of megahertz, in theory, you can transmit at the same time, and the receiver, who knows the spreading sequence, can unspread it, and at the receiver decorrelate it, and you, in theory, can get simultaneous use. Well, this became an issue of the haves versus the have-nots, and what are the costs and the benefits of this whole thing. And it's interesting that the cellular users, starting with second generation cellular licenses, paid for their spectrum with auctions, at auctions. And they said, well, we paid for our auction, it would be breach of contract. To which I would say, A, the law in the United States very carefully says you do not own your spectrum. But more importantly, this provision of the FCC rules that allows people to use various frequencies without a license at low powers, the first auction was in 1995, and that rule was adopted in 1989. It's 6 years if I count right. So Sprint conveniently forgot that little detail. So FCC now allows ultra-wideband, although I must admit it hasn't been a great success. Light squared is the current ongoing controversy dealing with GPS, and depending how you feel, it's either the best thing since sliced bread or the worst thing since the Black Death. Light squared is a satellite company that's authorized to provide mobile service from satellites. It's sort of like Iridium. It was a mobile satellite company. Iridium's not a household word because mobile satellite is frankly not cost effective in urbanized areas now. The people who, when Motorola developed Iridium, they thought it would be, but because of other advances in cellular, it basically isn't. The only place you want to use Iridium is North Dakota, Africa, rural South America, and places like that. It's just, cellular is so much cheaper, except in extreme rural areas. And basically the spectrum that they have in that band is basically unused in urbanized areas. I would even think that, I would doubt anyone in Indiana is even using that is using Iridium-like phones in Indiana, because I suspect Indiana has virtually complete cellular coverage. North Dakota not, but Indiana, yes. I haven't looked at the map, but I bet it is. So since 2001, Light Squared has had FCC authorization to use base stations in that band using the oddly called ATC, or ancillary terrestrial component, a terrible word, but that's what they called it. They've had permission, maybe they had a few base stations in the band, but not very many. And a year and a half ago, they asked the FCC, could they sell handsets that only talk to their terrestrial base stations? Under the 2001 agreement, they could sell handsets that talk to their terrestrial base stations, but only if they included in the satellite capability. But since in the vast part of the United States, nobody wants to use the satellite capability, why pay the cost or pay the weight penalty? Suddenly, the GPS industry woke up. The GPS industry knew about this, had filed comments on this, and indeed had insisted around 2004 that Light Squared's predecessor put an unprecedented amount of filtering on their systems to control their out-of-band emissions. So the cellular industry, the GPS industry knew about this, but had not paid any attention to it, except in a few cases, and suddenly they had a temper tantrum. Let's look at the technology of what's going on here. Okay, here's a GPS satellite. It's not in geosynchronous orbit. It's 12,000 miles away though. It transmits at 1575 plus or minus 15 megahertz to the GPS receiver in your car. Okay. I hope you don't think the satellite and the receiver talk to each other and your car receiver discusses where you are. It doesn't, your car receiver only receives, it doesn't talk to the satellites, despite what they say in TV shows. It's a one-way communication only. The terrestrial base station would be much closer, possibly within a few hundred yards, possibly within 2 miles. It would be not in this band, but in the lower adjacent bands. But it could be a lot stronger than that signal. And real receivers do not have infinite rejection of adjacent band signals. Because if you built a filter that had a totally square edge, what would happen? It would ring forever. Remember realizable filters? Look up your textbook. Realizable filters do not have infinitely sharp corners. It would be nice, but you can't build a real filter that's infinitely sharp. Okay, but let's look at what's going on here. This is the GPS signal stream. The red signal is the one that your car receiver uses. It's a so-called CA code. There are multiple signals in the GPS spectrum. The CA code is the one that's meant for civilian use, is unencrypted. That's what your car uses. It's at 1575 plus or minus 15. Light squared originally proposed to be in these two blue blocks, then moved down to the red block. And so you have, I think, 40 odd megahertz separation between them. But here you get an argument, how much filtering is possible? I personally think the blue thing was incredibly naive to think that. Interesting here is one of the military signals actually significantly leaks out of the band, but nobody likes to talk about that one. But the other military signal is correctly within the band. If you see surveyors surveying using GPS, what they're doing is, in addition to using this signal, they're using the PY code. And the PY code is encrypted, so you can't get any information out of it. However, someone very cleverly figured out that there's the very same signal, synchronized in time exactly, is transmitted down here at around 1200 megahertz. And if you simultaneously receive on both frequencies and cross-correlate, you can understand what's going on in the ionosphere better and correct for errors. So the reason why your car GPS probably has an accuracy of 10, 20 feet, but surveyors use a GPS with an accuracy of millimeters, but the reason is they're doing a lot of other things. And one of the things they're doing is receiving here, cross-correlating. There are other things they're doing, but we won't go into that. That signal was not intended for civilian use, but is indeed used by surveyors. So the controversy in light squared GPS is, what is a reasonable expectation of receiver immunity in the presence of nearby signals? Infinite immunity is impossible because of what we discussed about realizable filters. Rejection is, to use economic jargon, is an externality. Anyone know the word externality? Externality is something that doesn't cost you. If you dump mercury in a river, it's an externality. Dumping mercury in a river poisons somebody else, causes real cost. But for the guy who's dumping in the river, it makes economic sense because he doesn't pay the cost of dumping it in the river. That's what economists talk about an externality. This is a type of externality too, because if you pay to limit the rejection, it doesn't do you any good if you can lean on the FCC to get the other guy out of the band. So from the people who make GPS receivers are stuck in an interesting economic scenario. Why should they pay to make better receivers and pay at least the one-time engineering cost and the uncertainty to do that when they can lean on FCCs that keep the band empty? Now, if you keep the band empty, you have the problem that society has a resource that it's not using, and if use of communications resources helps the economy and helps society, there's a real cost to society of keeping spectrum fallow. And it's weighing these things. If you wonder why isn't this a technocratic thing, these are societal judgments, ultimately. And why a place like the FCC has presidential appointees is because these problems are not subject to closed form analysis. Closed form analysis is a key input, but ultimately weighing different social values is something political appointees are maybe better at than traditional engineers. But traditional engineers have a key role in explaining what the issues are in this. How do you balance this? This is why the controversy keeps going on. Now let me talk about on lighting candles as opposed to cursing darkness. Okay. A lot of people curse the situation and say, I never want anything to do with this. Let me say, if you want to get new technology in the world, it's better to light a single candle than to curse the darkness. This particular lighting candle, sadly, April 16th was the 5th anniversary of the disaster at Virginia Tech, and this was a picture of Virginia Tech on Monday. But I thought it was a good example of lighting candles to light the darkness. I think engineers should be more involved in spectrum policy deliberations to expedite the introduction of new technology, encourage capital formation for R&D. Let me tell you, it's nice to think of NSF as a source of money, but the private sector can be a source of money too. If the private sector gets frustrated with wireless technology, they're going to invest less in R&D. So there's a selfish motive for those in the technology business, but it also contributes to the general welfare. How to get involved. Learn how to access information on pending policy issues. And one of the nice things about we now live in the internet age is, when I first started working at FCC, it was impossible to find out what was going on unless you bought newsletters that cost $1,000 or $2,000 a year. Now there are lots of newsletters and blogs that are free. I don't buy the $1,000 newsletter myself, but there are several. If you go to my website, which I'll show you at the end, I have links to various blogs and free newsletters I get. It's easy to follow. Encourage students and faculty to do analysis of technical issues that are subject to deliberations. I think a term project, a thesis on a problem that's really under consideration is a perfectly legitimate piece of academic study, and it's useful. Okay? File comments. Comments means FCC, in the US administrative law system, US agencies, be they FCC, EPA, the Nuclear Regulatory Commission, depend upon comments that the public submit. They can be just saying, I think A is good, B is bad, or they can be technical comments saying, here's my review of the issue. The US legal administrative system depends critically upon comments that are filed by the public. I am active in IEEE USA. I am chairman of IEEE USA's Communication Policy Committee. I would be very much welcome student faculty to get involved in that because frankly I need extra hands anyway. So next, I wrote a paper. I have a position in ComSoc as the associate editor of Wireless Communications Magazine for policy issues. And there's an article I wrote in December on research topics that have policy, spectrum policy. These are areas of technical R&D that address interesting questions today. Merging silos, stovepipes. What that is FCC and other regulators traditionally have bands that are allocated only for very, very narrow uses. But the problem is that in a given spot, in a given time, most of these narrow uses don't occur simultaneously. And that's why most spectrum, most of the time, is idle. And for example, the wireless microphone uses, like I have this wireless mic, but it's only recording here, this has almost exclusive use of a band, but frankly, wireless microphone use is very heavy on Broadway in lower Manhattan in the evening. But averaged across the rest of the US, it's nil. It's pretty heavy at Disneyland and Disney World. It's heavy in Hollywood, but in most of the US, most of the time, it's nil. And yet, we tend to be setting spectrum aside for very narrow uses, and grouping wide set of uses would be useful. And one of the things I have suggested, the cellular industry, which has total control of their spectrum, could be squeezing in between existing cell phone uses, short-range communications like wireless microphones, like in hospitals, if someone's critically ill, but well enough to get out of bed, they give them a wireless EKG. And FCC jumped through hoops to give the wireless EKG industry for that. I think that could be done on cellular spectrum too. It's like wireless microphone, very short range. If you control the spectrum, you can find holes where you can get short range communications. There's not been much effort in that. RF illumination of suburbia. Cell phone systems need towers to light up the areas where they are. Most cellular towers look like they were designed by engineers, and I mean that negatively. Where was that tower we saw last night? The two towers? And
I wasn't with you, but I'm guessing it was the one down.
there was a pair of towers pretty close to each other near downtown South Bend. Two of the ugliest towers I've seen. It was interesting, two towers like 100 yards apart that visually had absolutely nothing to do with each other. And people wonder why neighbors don't like towers. We want to illuminate suburbia with cellular signals. We want the cellular signals in terms of the input to a receiver to be in the range of -80 to -40 dBm. Some people say, well, more is the better. No, you do not want very strong cellular signals, mainly because they cause more problems with receivers than they cause benefits. You really you may want them stronger than -80, but you don't want them stronger than -40. Because there are some second order domino effects when you do that. Figure out more efficient ways of lighting up suburbia that's compatible with the neighbors. And let me point out that the stealth bomber was designed by electrical engineers and aeronautical engineers who worked together to design a bomber that could both fly and be invisible. I think what we need is take an architect out to lunch. We need to have teams of engineers and architects figuring out how do you illuminate suburbia with structures that are compatible with suburbia. Unless you think I'm totally crazy, 3 months ago in Spectrum, IEEE Spectrum, there was an article about a design contest by the British electric power industry of new ways to design high tension power lines that are more compatible with the countryside. They got architects to work with electrical engineers, in this case power engineers, to do that, and they came up with some very novel ideas. Radar communications spectrum sharing. Conventional thinking is radar and communications can't share. Without going into details, read my column, other columns of mine in this wireless communication magazine. I think radar and communications can share if we think out of the box. Filter equivalent of Moore's law. Wouldn't you like to have a law named after you? Moore has a law named after you. Metcalfe has a law named after him. You can get a law named after you if you could come up with a Moore's law equivalent that describes how filters have improved over the past 30 years, because filters have improved. The problem is it's hard to quantify as easy as Moore's law, but filters are getting cheaper, smaller, and sharper. But no one's done a constructive analysis of that and projected it, so you too can have a law named after you. Look at the performance of filters over the past 30 years and write your own Moore's law. When you like to do it, you'll be eternally famous. Cognitive radios, most people think of cognitive radios as a way to find an idle frequency. A different variant of that is if you know the population of receivers around you, and if you know the quirks of receivers around you, you can pick a frequency that is both idle and will not cause interference to your neighbors. Because of intermodulation and other factors, there are idle frequencies that actually cause interference. So Preston Marshall, who some of you may know, used to work at DARPA, now works at USC, was the first one to raise this point to me, is if we could pick frequencies better, we could use cheaper receivers, because good third order intermod performance is expensive. But if you could pick your frequencies better, you could avoid this. And a final issue is propagation models for cognitive radios, because cognitive radios, turns out, depend critically on propagation models, and most people don't understand that. So let me thank you for your kind invitation. This is my website. The website is marcusspectrum.com. At the end of the website is a page called Spectrum Links. If you need more information, you don't want my self-promotion, just go straight there. And there's all sorts of useful information on technology policy and regulation. There's also a blog, which is there where you can get my quirky views of the world, and I would be glad to answer your questions.